Hi folks, we're going to take a look at number 12 on page 268. So here they want us to find the slope of the tangent to this curve at the point where the curve intersects the line y equals 3x. Now first of all, I notice that I've got a parabola and I'm looking for the point where it intersects a line. So there's a possibility that there's no answers because we have parabolas that don't intersect lines. There could be two answers where the parabola intersects the line twice, or of course there could be one answer if it just touches once. All right, so I have to be prepared for more than one answer. So before I can know where to find the slope of the tangent, I need to find these points where the curves intersect. And so here we can just do a substitution. Since I need these to be intersecting, this y here needs to also be equal to 3x. So I'll set up an equation. 3x has to be equal to x squared plus 9x plus 9. Okay, so I'm left with a quadratic equation, not surprisingly, since I could have up to two points of intersection. So I'll bring everything to the other side. So here we've got x squared plus, this will be 6x plus 9. But I see that when I factor this, okay, I have x plus 3 squared. Okay, so when is this equal to 0? Well, when x is equal to -3. So there's only one point of intersection, and that occurs when x is equal to -3. So if I want to find the slope of the tangent to this curve, where it intersects this line, I know that that's going to occur at x equals 3. So to find the slope of the tangent, well, I just have to take the derivative. So y prime is equal to 2x plus 9, and then I want to find the slope of the tangent at -3. So that's 2 times -3 plus 9. So -6 plus 9 is equal to 3. All right, so there's the slope of my tangent. Now, I actually say that we shouldn't be surprised by this value here, because what did we just determine? Okay, we just determined that, this function here at -3 is where it intersects the line y equals 3x. And since it only intersects that line once, the only way for that to happen is if it's tangent to the curve. Okay, I didn't quite draw this very well because obviously it should have been a positive slope, but this is just to show you that because this line only intersected the parabola once, we should have known that this line was tangent, hence had the derivative included in it. The slope of the line just ends up being our derivative here. Okay, but even if you didn't notice that, the algebra will take you there. All right, so just to recap, okay, if we want to determine where something is occurring, what's occurring when two functions intersect, well, the first thing you have to do is determine where they intersect. Once you have that value, then you can solve the problem. In this case here, we needed to know the slope of the tangent at that point of intersection. Hence, we had to find the derivative at that x value where the two curves intersect. Okay, that's it for this one.